All right. Can you guys hear me back in the back? Cool. All right. It's a minute after 10, so we'll get started. My name is Mark Hinkle. I am the Senior Director of Open Source Solutions at Citrix. And today we're going to talk about the Hitchhiker's Guide to the Open Cloud. So anybody here, Hitchhiker's Guide to the Galaxy fans? I will make thinly veiled references to that stuff. The rest of you, I will try and keep them to a minimum.
And your last slide says 42.
I know, it's that predictable. I know. So should I just skip to the end? In the last session, I think the discussion started with, is there too much fragmentation? Do we have too many choices? My assertion would be no. I think choice is good. The reason we do open source is because our other alternative has lock-in and lack of choice. And so what I'm going to try and do today is give you the overview of the open source cloud ecosystem and try and tie that all together so you guys know where to look. These slides are on SlideShare, and so I have tons of links when I make slides and speaker's notes so that if I talk about something, you can go find it later and just download it. So don't worry about furiously writing down anything I say because it's probably not right or interesting, but it should be funny. So a little bit about me. I'm an open source guy. I work on open source stuff at Citrix. Primarily, I work on the Zen project, Apache CloudStack, and Daylight, which Daylight and Zen are now collaborative projects in the Linux Foundation. I've also done a lot of other things in open source. I've been in the media. I worked for open source startups. So I'm about open source software, and particularly enterprise open source software. That's sort of my background, my point of view. And I got to work with a lot of these companies, a lot of these projects. I want to give you guys sort of an idea of if you want to do cloud stuff, what open source software is out there, what holes does it fill, how does it all fit together. So I always put this in here, why open source, but the biggest thing I think that I like about open source in the cloud is that it's user-driven. Despite working for a software company, I think a lot of times software companies have solutions looking for problems. Open source software is typically user-driven innovation, so that context helps solve those problems better. Also in the cloud, as fast as things are moving in cloud computing land, the open source tendency to release early and often, I think, are all good things to stay current and stay on top of it. So if you want state of the art for cloud computing, open source is where it's at these days. So I'm going to give you like the 3-minute overview on cloud, so we're all talking about the same thing. When I first heard about cloud, I thought it was sort of like the infinite improbability drive, you know. It was just a magical thing that just worked. It really isn't. There's still an architecture to cloud. There's still software dependencies. The thing that's interesting about cloud is the 5 characteristics of cloud. Probably the most interesting one to me is on-demand self-service. So in my old days as an IT director 20-some years ago, I used to, whenever I wanted to provision a service, I would call Dell and they would ship a server and I would carry it to a rack and I would plug it in and I would bust my knuckles and then I would cuss and then I would work on the network. So on-demand self-service is really interesting to me because you have this pool of computing, everybody can access their stuff. Broad network access, typically in the sort of public cloud space, that means you have multiple routes to the cloud. This is the NIST definitions of cloud that I think is generally accepted as cloud definition. Even if it's a private cloud in your own data center, having good network connectivity where that's not the choke point is important. Resource pooling, you know, the old days, you had individual servers, then you virtualized the servers, now you pull those virtualized servers. Elasticity is probably one of the more interesting ones as well, is where you can take advantage of what you need and it's metered when you need it. So if you need a lot of compute, it scales up. When you're not using it, it scales down. You're charged by that measured service. 3 quick definitions. SaaS, that would be Gmail, Salesforce.com. PaaS, this is the interesting stuff I think to this group, is the development cloud. That would be environments that abstract out the operating system, the infrastructure, so that you have a sandbox to deploy your apps. This is sort of the improbability drive of the cloud, actually, because it sounds too good to be true, and it's not really in wide production right now. And then infrastructure as a service, and that's what I think most of us talk about when we talk about cloud today. That's things like Amazon EC2, that's things about Amazon S3, Google, Google App Engine, or Google Compute, things like that. So those three definitions are what we're going to talk about, and really the PaaS and the IaaS, which some people just call AAS, which I find interesting. So, deployment models. The three deployment models for cloud are the private cloud. That means it runs in your data center. And things like OpenStack, CloudStack, Eucalyptus, OpenNebula are things that you use to build a private cloud. Public cloud is things like I mentioned earlier, like Microsoft Azure, Terramark, Google App Engine, Amazon. They're running in somebody else's data center. Inside of that, they have these new offerings, which are highly secured private clouds within a public cloud. If that makes sense. I think that's more of a service offering, but typically, and people call that a virtual private cloud. And then there's this thing called hybrid cloud. Hybrid cloud is the idea that you would have workloads that you deploy between public and private. And you would auto balance across those two. So that is the three the definitions I wanted to get to you. Now let's get into the open source software. So when we look at this PaaS layer, SaaS layer, they're all sort of subsets of each other. We have physical resources in the bottom, things like operating systems, VM managers that abstract that out. Then we virtualize those resources, network, compute, storage, and then we have these service models of SaaS, PaaS, infrastructure as a service. So you may have an infrastructure as a service like an OpenStack running a PaaS like a OpenShift, and then you might develop an application that is a SaaS offering on that, and then users consume that through APIs, browsers, other tools, and that's sort of that overview of the architecture. Does that make sense to everybody? The only reason I did that is so that we're all on the same page when I have the conversation about cloud, because I think 80% of the people here know that, but the one guy who's sitting there going, I'm not with you. Now we're going to talk about the software to build this. And we're going to start with the hypervisors. So yesterday we announced the collaborative project with the Linux Foundation, the Zen project. In the cloud space, we have the Zen Cloud Platform, which is a set of tools in the Zen hypervisor that allows you to abstract your compute resources. KVM, kernel-based virtualization. Everybody, this is Linux Foundation. Most people talk, that's one of the most talked about kernels out there. It's a level of virtualization that runs in both kernel space and user space. Then these other three, I'm not going to really talk about them, but I want to put them in the list because they're a little different kinds of virtualization. The two that I think are most popular in the cloud space right now in the open source would be Zen and KVM. The other ones are a little more specialized. The one that's interesting, the one that I see a lot of people that run in the app space, that run like apps that are large instances with many, many individual instances of apps, like app servers and things like that. They're using the LXC containers, and they're seeing some good results. A lot of the solutions I'm going to talk about today uses LXC, but I would say general purpose is Zen and KVM. LXC is a little different. VirtualBox, OpenVZ has some really interesting stuff, but that's also one of those solutions where I've seen people who have the same kind of application that they want to virtualize and run over and over again versus disparate workloads that they want to run and deploy on images on their operating system. Then there's the proprietary ones, VMware, Citrix Zen Server, which is based on Zen Project. Just got cut off there. Microsoft Hyper-V, Oracle VM, which is also based on open source Zen as well. So those are the hypervisors. That is as I look at the cloud, there's three things you're going to abstract, right? Your compute, your storage, and your networking. This is the first part, compute. So this would be the Amazon EC2 part of virtualization. We're going to split those servers up. When it comes to deploying payloads or workloads on these hypervisors, each hypervisor has a certain image format that they use. This is what's confusing and frustrating to a lot of people, I think, because if I have this operating system image, I want to deploy it on VMware, and then I want to deploy it to Amazon EC2, and then I want to deploy it to an OpenStack cloud, you got to do some stuff to move it around. So there isn't a great way to take that workload, that stuff that you want to run in the cloud, and move it from cloud to cloud. So open virtualization format is probably the only open standard that's very specific to cloud right now. What that is you take your machine image, some metadata, can I say that one more time? Metadata, combine it into a package that you could deploy on different hypervisors. So VMware can import that, different cloud providers can import that, and you can move that payload around. Except it's not a live running image, it's actually a snapshot in time that you're moving around. Formats for these hypervisors that I was talking about early, or for these compute technologies. Amazon is an AMI. Amazon is part of the Linux Foundation Zen project now. And so they run a very slightly modified version of Zen. KVM, they have their QCOW2. VMware has their VMDK. Zen project, you can have raw image files. VHD is the virtual hard disk files for Hyper-V. That's actually an open standard that Microsoft donated. So 10 years ago, I would not be talking about open standards that Microsoft pioneered. I think that's a good sign when we start to win and people start accepting the idea of open standards and open source. So when you create these images, you can mount a CD or mount a file system and install this stuff, but that's cumbersome if you're going to create your, what I call the gold master that you deploy over and over again. A lot of people have that mentality. Is it just me, or is that color just changing back? Okay, it's late. I'm like, I thought I got some bad mushrooms at the party last night or something. So, okay. I've tried that. It's actually all the way in. Okay. All right, it's still yellow. Sorry about that. At least I'm not going crazy, or at least that's not the reason why. So these images, you can either create them yourself from installing them from your operating system, repositories, and installing applications from whatever source you want, or these open source cloud appliance solutions out there actually let you roll these appliances. And something that I see that's sort of avant-garde in the whole provisioning space right now is people are actually rolling juice OSs, just enough OS, with very specific applications. The reason why we call them appliance is because they do one thing. Toaster does one thing, burns bread. These things are all solutions for SUSE Studio is a hosted solution. You can actually call through their API and spin up a SUSE image with just the packages you want and deploy it right to your cloud. laaS, Box Grinder are actually open source projects that give you a tool set to create them. And then Bitnami is actually just announced their Y Combinator project, but they have Bitnami has an open source software repository of images that a lot of people deploy them right to Amazon. So, and they are all open source software, and that's why they can distribute them. The other thing when we talk about the cloud is this idea of elasticity. There's two kinds of elasticity. There's what we call scale up and scale out. Scale up is where you increase this, you add additional resources. So if you say HA proxy, where you're adding additional worker VMs to your pool, that is what we all Did I just mess that up? I just reversed those two, I'm sorry. So vertical scaling is, or scale up means that the size of your image increases. Scale out means that you would have a distributed thing like HAProxy, where you're adding additional workers, and there's some kind of master that's distributing workload across those. Those kind of things, the scale out stuff, you have to have that logic in your app. The scale up, you have an image size, and it has a finite amount of compute and memory, and maybe even storage attached to that. And if you want to, if it's all enclosed into one offering, for you to get more memory or more compute power or anything, you would reboot it, and it would have a bigger footprint than it did before. That's the difference between the two. One is disruptive to your availability. The other one, if your application has that logic, can scale out. So now let's talk about, and disclaimer here, when it comes to Zen, it comes to CloudStack. I work on those, Project Daylight, very biased. They're my favorite. If I come across that way, I want it to be clear what I work on. These are all fine solutions, and you guys should make your own choices. But for compute cloud, so if I want to create my Amazon EC2 kind of experience with open source, first one, Apache CloudStack. Apache CloudStack is a top-level project in the Apache Foundation, like Hadoop, like Cassandra, like the Apache web server. It's been developed since 2008. It is open source Apache licensed. Those are all Apache projects. It has a large user base of people running service providers, end user clouds. So let me think who's a good example. Zynga, the guys who bring us Farmville, they run on a CloudStack-based cloud. Spotify, Tata Communications, Korea Telecom, Edmunds.com, all these companies, probably about 150 companies that are Citrix customers, probably 5,000, 10,000 users that are running these in production for service providers, like Green Cloud, which is a carbon neutral hosting provider in Iceland, OpenStream, or PC Extreme in the Netherlands is another service provider running open source. The difference in their OpenStack or Apache CloudStack is it's an all-encapsulated, all-in-one solution. So it's pluggable, but when you deploy Apache CloudStack, you should be done with, at the end of it, you should be able to give your own Amazon EC2 style experience, or infrastructure as a service compute cloud. Eucalyptus, they do a lot of the same things that CloudStack does. Their sort of hallmark is that they want to keep high fidelity with the Amazon API so that you don't have to switch back and forth. OpenNebula, they have a lot of success. They're European. They have a strong European presence. They're very popular in the research and development, sort of that next generation HPC space. You could do a lot of things with OpenNebula, but that's where they're popular. And then OpenStack. OpenStack is probably the most well-known of the open source clouds. They've done a great job of marketing themselves. This week, OpenStack is having their user summit same time as the Linux Foundation. So there's probably not a big cross-pollination of users between the two. They're huge. They actually are so huge that they go beyond what the other ones do because they're a whole ecosystem of projects. So I decided to give them their own slide. So they have a project called Nova OpenStack Compute, which is the square there on the right-hand side. Nova is the equivalent of what Apache CloudStack, Eucalyptus is. They also have about 25-ish projects, keeps growing, that they're a collection of projects you can put together to build a cloud, and they span not just the compute, they span object storage, they span networking. Their code name is called Quantum. They have an enterprise message bus based on RabbitMQ. They have all these parts, and you put them all together, and you can do storage, you can do networking, you can do compute. You can do it all from one project, even though there's tons of different vendors working together, and the projects are sort of siloed, but they all work off of the identity services project, which is called Keystone, which is the thing on the left. It's very hard to keep up with all the stuff that is OpenStack, but I thought this sort of gives you a good overview of the key components. And they have other things that are interesting, like Crowbar, which is a bare metal provisioning tool. Things like Apache has a solution for bare metal provisioning as well. But they are very much a vendor-led project and have tons and tons of people contributing to doing that. But I would say it's more like if you wanted to compare the ones, this is like going to the supermarket and picking out your groceries and going home and cooking dinner. The other ones are probably closer to just going out to eat and having it served to you the right way. Varying levels of service at each one. Okay? So I've been trying not to go too deep into details, but here come all the Hitchhiker's Guide. So Babelfish is, a Babelfish is what happened in the Hitchhiker's Guide, where when Arthur was going around the galaxy so that he could hear, they put this fish in his ear and then he could understand everything. So cloud APIs are sort of like that. Every cloud has an API. Not all APIs are consistent or created equal. So there is a whole class of software out there called, the JClouds guys like to call it cloud controllers, which is really a library. JClouds is like a Java library that allows you to write to one set of API calls and have it translate to Amazon and Apache CloudStack and OpenStack so that you don't have to instrument your management tools to multiple cloud APIs. LibCloud's another one. Delta Cloud, it's technically Apache Delta Cloud. Fog is another one. All these tools are there so that if you want to automate your cloud, you want to write to a certain API, you don't want to have to learn every API and every nuance. You have one API, and then it can control not just a single cloud, but multi-clouds. Or it gives you the advantage of switching to other clouds later on. So we sort of hit the compute now, and we talked about APIs, because most of the compute clouds, that's what there's a lot of debate around. The next thing we're going to talk about is cloud storage. So early in the talk before us, we heard people talking about cloud and having storage available in a distributed fashion so that you could have redundancy. You also had low latency between your data and your compute. A lot of people still use their legacy storage solutions. They NFS amount whatever they have already, or they run local storage with their VMs. These storage solutions are usually aimed at having distributed storage of two different types, and it's usually object. A lot of times we're talking about object stores. Sometimes we're talking about just distributed redundant file systems. Ceph is a really interesting project. Their distributed file system, earlier on I said the reason I like open source is because they're driven by user-driven solutions. Ceph was developed by Sage Wheel, who started DreamHost, which is a big hosting provider on the West Coast. So he was a ISP, or a hosting provider. He had this problem. He solved it with Ceph. GlusterFS is a scale-out NAS system. Aggregate storage over fiber, or Ethernet, or InfiniBand. And Gluster was a startup that was acquired by Red Hat, and Gluster community, gluster.org, is shepherded by Red Hat. They're sort of in the same space as Ceph. OpenStack storage is a long-term object store, a lot like this would give you the ability to create an Amazon S3 style object environment if you wanted to do your own. Another one that's really interesting and just recently open source is ReactCS. React is a NoSQL database. They have created a solution with an S3 compatible API, so we go back to the Babelfish thing. There are a lot of tendency for cloud software providers is to create an API that has some level of fidelity with Amazon, because a lot of people use Amazon. They're a leader in the space. There's a good reason to use Amazon. There's a good reason to do your own. Just make sure that you have the right reason to do the right thing, and that's complex. The last thing is Sheepdog. So if you're a KVM fan, Sheepdog is a distributed storage solution for KVM. It is championed by, I should know, it's either, I want to say Fujitsu or Hitachi, but this is another user-driven storage solution. It's specifically for KVM hypervisors, but if you're looking for a good commodity solution for KVM, Sheepdog has integration on that side. Those are just some of the cloud storage solutions out there. There's plenty of proprietary ones. These are the open ones. And there's probably more open ones. These are the ones that I think are most popular. So we talked about infrastructure as a service. The next thing we're going to talk about is platform as a service. So this is sort of the magic of the cloud when they describe cloud to me, is I was just going to upload my application, and it was always going to have the resources I need. It was always going to run, you know, with 100% fault tolerance, blah, 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 blah. This is sort of where I think is interesting as far as that sort of holds that promise. Basically, you develop your app, you put it in this container. This container abstracts out all the storage and all the compute and all the networking. And as a developer, this is your developer cloud, your developer sandbox. That is the promise of PaaS. I don't know if it's really there because I am not a developer of software personally, but it's the most interesting to me because it gives me the same kind of flexibility, and I can actually focus on developing applications instead of provisioning hardware and compute and networking, etc. The popular ones here, there's CloudFoundry. CloudFoundry is an open source project that is was started by VMware. CloudFoundry has a large following. It doesn't seem, last time I looked, it doesn't seem like it's open source license, but it doesn't seem like there's a lot of outside contribution to the core code from outside of VMware. But there's a lot of people using it and doing cool integrations with it. Cloudify is sort of different from all the rest of them. So how many people here know what DevOps is? So DevOps is sort of this idea that your developers are going to talk to the operations guys so that they don't just throw over their code to the fence and say, make this run. And they typically work on a process to roll out their applications so that it goes from development to deployment through some kind of continuous deployment process that is very agile. There's a lot of principles from like agile development. But Cloudify, to me, has more of a continuous deployment kind of mentality. So tools that would actually build the software like Jenkins and then run their unit tests and then deploy it into production all through some automagic process. Check it out as source code, call cloud APIs. That's sort of the orchestration of deploying the app that seems a little less, that seems more transparent to what's going on, but not quite as abstracted as I would look at something like OpenShift or Staccato or Cloudify. And speaking of OpenShift, OpenShift is the Red Hat version of the Red Hat PaaS. It was from a company called Matacura, and the reason I had stars there, and I actually took away the notes and I left the stars, was it wasn't open source when I first started doing this, and now I believe OpenShift is complete. Origins is the open source project, and OpenShift is actually a free hosted PaaS sandbox you can play around with from Red Hat. Staccato from ActiveState is interesting. They're sort of a value-added CloudFoundry. And WSO2 Stratus is sort of in that same category as Cloudify, sort of the tools to bring your apps into the cloud. It's sort of that could be a whole day conversation of what those differences are, but I wanted to touch on them. So here's the new thing that I think is the 3 layers of abstraction. There's the compute, the storage, and the networking. In the networking space, I think this is where we're the last final frontier. So last week, the Linux Foundation announced the Open Daylight project. This is the last part that we need to be truly agile in the cloud. Because right now, we can start and stop images. We can move those virtual machines around from cloud to cloud. We can move storage around, but we don't have a lot of great solutions to, when we're moving that storage around, to dynamically reconfigure our network. And that's where SDN comes in. So SDN, typically, this is sort of just a very simple diagram. SDN is really having a software, a separation between the software control plane and the physical control plane, and then having either a northbound API so that there's some API for the business applications to call, a southbound API so that there's a way for it to interact with the devices. The typical thing that people talk about in SDN is OpenFlow. We'll touch on that in just a minute. So in the cloud, the thing that we like about the cloud in the way that we consume like an Amazon EC2 is that it has central configuration and management. We have the ability to self-service and provision. We have the ability to scale up and scale down, and it's designed for failure. In the traditional networking paradigm, there are wires plugged into routers connected to other routers, and that is how the network is run. What we're talking about in SDN is actually the ability to create routes and route those packets without having to touch the wires, without having to touch each individual device. And one of the most popular ways to do that is, and the open standard would be OpenFlow. So you have some kind of controller that is out there, and it's securely telling these OpenFlow-enabled switches and routers how to forward those packets across. So that if I have a cloud where I have an East Coast and West Coast data center, and I have one in Asia, and all of a sudden I reconfigure where stuff is being served from, I have a central place to reconfigure and reroute all these packets around. So, as I've done with each one of these things, in the software-defined networking world, it's moving really fast. There's a couple I'm going to mention probably that aren't on here, but the one that, since we're at the Linux Foundation, I think is most worthy of noting right now, or has the really good potential, would be the Open Daylight project, which is a consortium of networking and end users. So it has Cisco, IBM, Red Hat, Citrix, Brocade, Big Switch Networks, Alcatel, Arista Networks. All these networking companies have come in together to come up with a standardized open source software-defined networking platform that's pluggable. And then they will work together to plug in different levels of enhancement in that for different levels. If we talk about the 7-layer model, the application layer and the security layer, et cetera, that is Open Daylight. That's the one I think is really interesting in principle, because we just dropped the code last week and have started to hack on it. So that one is a broad industry move backed by Linux Foundation, but the software right now is not a solution. The other ones are a little farther away. So Floodlight is a Java-based OpenFlow controller. Indigo is another one. As I gave you that OpenStack diagram earlier, Quantum or OpenStack networking, they have a solution. Open vSwitch, it's sort of a different class. It's usually integrated at the hypervisor level. You guys heard of Nicira, which is the VMware SDN solution. They spent $1 billion for this company recently. They do a lot of work on the Open vSwitch, which is a virtual switch. It solves the problem of having the network go along to be dynamic along with your virtualization. And so Open vSwitch is integrated with things like VMware and Xen Server, et cetera. Okay. All right. We're covering a lot. So there's my next big data. Deep Thought was the supercomputer that's crunched and crunched through all the data to come to the answer that everybody wanted. So I could give you the sort of big data overview. We're creating lots and lots and lots and lots of data. And not all that data is useful. In the old days, you had databases, SQL databases. You collected lots and lots of structured data, and you mined that in a certain way. In the sort of big data NoSQL world, people are getting these massive amounts of data that are unmanageable under the traditional data warehousing paradigm. So here's just an idea of, for example, our Facebook, how quick Facebook data is done. How many 400 million tweets a day in June 2012. Problem is, a lot of that's garbage. Like, who cares about the picture of my breakfast that I posted to Facebook? Who cares about the tweet that says, I hate TSA because I got filled up for the 100th time? I don't care. But if you're trying to get through this Twitter stream of data, you want to have tools that actually can crunch through that. So the point being that data is growing faster than storage capacity and computing power, and these legacy systems are holding us back. So they had to come up with a way to harvest this data and make it useful. So how do I take my tweet stream and make it useful? Or actually, it's not me. It's how do the advertisers that keep Facebook running go through my tweet stream or my Facebook stream and figure out what they want to do. Or, my GPS and figure out what I've been doing, et cetera, et cetera. I just put this in here for you guys to download. This sort of has the breakdown of the whole big data landscape. So if you're looking at certain proprietary solutions that you have, you might want to find the open source solutions in there. It's a massive, massive, huge market that's very complex, and people much smarter than me do that. But at the end of the day, there are tools at virtually every level of that data stack that are open source and evolving very quickly, actually much more quickly than some of the traditional database apps for these special use cases of massive amounts of data that I want to sift through and find something useful to. First, we're going to talk about how we store that data, and that would be NoSQL databases. These are typically key value pairs stored in a database. There's some kind of hash that keeps that allows you to store this data and access it in a very, very efficient manner. It is, unlike a SQL database, it is not lots and lots of rows and columns. It is key value, too. The ones that are interesting, I've listed here. Each one has its own specific use. Some are document stores. Some are expanded to do object stores. They have different end value. React was actually, we talked about earlier, React CS. They're using that to store as an object store. The underlying technology for their object store, React CS, and CS stands for cloud storage. CouchDB, MongoDB is backed by a company called Tengen, very, very popular. I can't really go into what each one does in our short amount of time, but these are ones you might want to look at. I have an appendix in the back of sort of the NoSQL list of places to go and sort of shop around, because it just depends on what your use case is for that. But earlier I was talking about how we have all this data, and a lot of this data is crap. A lot of this data is interesting, and we got to figure out how we take that problem data and make it manageable. And the tool that we use to do this is something called MapReduce. So you have this big data set, and you have this MapReduce program, and it takes this data set, breaks it up into chunks, processes that data parallel, and then spits out some solution data. So the idea of MapReduce was sort of championed at Google. And typically, what you're doing is sifting through all this data and making it useful. The tool that I think in open source that a lot of people hear about, probably most useful is Apache Hadoop. And that's basically takes this data set, stores it in its native format, and then it gives you the ability to linearly scale at very low cost. It cloudifies your data mining. Now, it's a top-level project at Apache. I like Apache. I like the Linux Foundation because they're reputable industry sort of consortiums that ensure that these technologies are going to live on in a neutral way. It's a framework for storage and compute. So you have this file system, you have the MapReduce, and it has a domain specific, and it's written in Java. Just like I did with, but it's a whole ecosystem. There's tons and tons of projects that all feed into this sort of Apache architecture. And I sort of tried to break it down into something that was a little bit more manageable. So you've got your MapReduce in the lower left. This is the crunching things up and taking that big data set and making it manageable. You have Hive, which is a data warehouse. HBase is a distributed database for storing some of this stuff. Pig is a scripting language. Mahout's the machine learning stuff. All this stuff combined together creates your big data like framework. And then there's other tools to do data mining. And then you could, if you're using ETL tools and other things like that, you can actually pull things in and out of your existing data warehouses and use this Hadoop stuff. It's not trivial for me to explain, but the things that I wanted to get out of the big data stuff in open source is that we have lots and lots of data being created out there. That before what we would do was batch it up and do data processing sets that just ran overnight, and the next day you got reports. Now people want real-time access to data, so you need to have low-cost, highly scalable solutions process that data. Because we have cloud services out there that actually make it easier to deploy this, there's actually NoSQL providers out there. There's Hadoop providers out there now that are actually hosting Hadoop, so that you don't have to deliver it, and you can just consume it on a as-needed basis. We have more and more databases, data sources being meshed together, and we've got to figure out how to normalize that data and how to process it. If you try and normalize big data sets, you'll never get it done. You've got to normalize the information that you want to keep in the long term and throw away the garbage. So that's sort of my big data thing. I think everybody hears that buzzword. I wanted to give you the open source viewpoint on it. I also wanted to tell you that of all the things out there, I don't see any more cutting edge development and solutions being developed in the proprietary world. It's all in open source. It's largely around Hadoop. It's a huge ecosystem. I don't know that I've actually saw, the thing I thought was interesting was Teradata. I'm an investor in Teradata, by the way, so if I don't know if I have to do the forward-looking statements or whatever, but Teradata is a big data warehousing company. They have lots and lots of billions of dollars of revenue and proprietary data solutions. They have a Hadoop offering now. I thought that was really interesting as I was reading through their website a couple weeks ago that these tools are not being developed by the big companies, the big software companies. They're being adapted to their existing data and analytics tools. This is the last thing. I come from an ops background. I'm going to go through these tools rather quickly, but as I said, they're all downloadable. I think one of the biggest things that we have to overcome to be successful in cloud computing is the speed. So, and earlier today I was talking about, in the old days, I would call Dell, and Dell would ship me my server, and I would rack it and stack it. Now, I go to a web page, I log in, I hit a button, and I can spin up like 1,000 instances in under an hour. I mean, just thousands of machines. So that ability to deploy infrastructure has been very, very automated. The problem is I can deploy it, but if I deploy 1,000 images at once, I can't keep up with them. Today we are the meat cloud, the guys who operate data centers. We do not scale like that. So we got to figure out what our robot army looks like and automate all these things so that when I spin up my 1,000 instances, not only do they start, but they do something useful and they stay up and they are, they can handle the changes. So there's this theme of automation in the cloud. There's 4 types of tools: provisioning, configuration management, orchestration, and monitoring. On the provisioning tools, we talked a little bit about provisioning the cloud images. But what I want you to walk away with is that when you look at the cloud, and even in regular operations, you want to come up with systems where your one tool, the output of one tool informs the input of the other and creates a tool chain, just like in developer tool chains, so that if I provision something, it automatically kicks out to my configuring tool. My configuration tool tells my monitoring tool to start monitoring this because it's configured enough, and this is what it looks like. On the provisioning side, there's a couple. I'm not going to go into all of these, but basically these tools actually kick off your individual image in the compute cloud. So Apache Provisioner, Cobbler, Crowbar, they're all usually tools around the operating system provisioning. Most of them rely on things like automating apt or RPM to actually provision these juice OSs that we talked about earlier. Here are the ones that I think are more interesting. I'm not more interesting, but these are the ones that are powerful in the cloud. So these tools have recipes so that you can take and automatically configure your guest instance in your cloud in the way that you want. So you can start and stop services, you can install software typically, you can configure the parameters around the software. Like Chef, for example, can call apt to actually update the packages and use your existing package management. The one that's sort of new and really interesting is Salt, and that one is actually has these, use 0MQ and actually goes out and can actually configure thousands of devices very, very quickly using these things that they call grains, which are little recipes. It's sort of a command control network. It is not specific to config management because except the fact that it can use these little recipes to do stuff on the machine. So it remotely executes commands securely and on a low latency open protocol. Automation orchestration tools. The ones that I think are really interesting are, if you're a Puppet user, mCollective automates Puppet. Funk, if you're a Fedora user, that's one of the Fedora projects. That is an orchestration framework. The ones that are really, Ansible is pretty new and was developed by the guy who developed Funk. And if you're familiar with Cobbler, which is the provisioner on the last slide, Michael DeHaan, that's his newest company, is basically a command and control framework to go out there and start and stop services, run scripts, etc. Another one that's very cloud specific is Scalar, and it actually does scale up and scale down of web services. Really cool. I've seen it in production. It really works for a lot of companies and organizations. That one's very cloud specific. So conceptual automated tool chains, and I'm hitting right at my 50 minutes now. The idea is that you will have your tools like SUSE Studio Box Grinder that would kick off a bootstrapped image in your cloud platform like CloudStack or OpenStack, or even you could theoretically do it with a public cloud too, if you're still in. Provision it using Cobbler, configure it using Puppet or Chef. When it's configured, it's going to tell Xenos, Nagios, Cacti, whatever your open source monitoring solution is, that it's up and running. And then you're going to use one of the orchestration services like Capistrano, mCollective, Rundeck to start and stop services. I didn't go into the tools that much because I think we have a lot to cover, but I think if you don't have the tools or know where to look for the tools to run your cloud, you're going to have problems. The other things that are interesting, how many of you were at Adrian Cockcroft's keynote? The tools at Netflix are very cool, especially if you're an Amazon user and you want to use open source tools. his stuff, he's running large-scale cloud. Check them out. I listed some of the ones I like. But when it comes to cloud, he already blew my big ending with the fact is the answer to everything is 42. Yeah. It was so obvious I know I had to do it. But the question is, I know, I edited a slide. It was synced up. But because I'm running low, I don't want to displace the next group. I'm not going to do questions here. I'll do a couple questions, but I'll stick around in the hall. So,
There's a break after the break.
oh, there is a break? Oh, then cool. Then we have plenty of time. So, all right. Any questions out there? And actually, Russ, could you do me a favor and hand the... I have a... Yeah.
Hi. I was wondering, I've heard some rumors that Amazon isn't that happy with Zen. Have you heard anything like that? Do you know what that's all about?
That Amazon isn't happy with Zen?
Yeah, that they're thinking of possibly, ripping it out and changing their architecture.
So Amazon doesn't like to talk about their infrastructure, and I can't comment on their infrastructure other than to say that yesterday we launched a broad industry initiative around Zen, and Amazon is one of the members, the founding members. So, I mean, I think you would have to extrapolate from that they're probably pretty committed to it,
Right.
as Google, as is Rackspace, Verizon.
So why did they choose Zen over, say, KVM? Or?
Zen predates KVM, I would say, is probably the biggest.
Okay.
So KVM, like I work with the Zen guys. Zen is sort of this type 1 hypervisor. There's a definition of type 1, type 2. And it runs in different sorts of user, and some runs in user space, some runs in a different level of security. I don't know that there's a reason to use each one, but it's for really geeky smart guys that are smarter than me, but it comes down to containerization and how in a multi-tenant environment Zen runs at a lower level where it has different separation.
Right.
KVM runs in some of the user space, and the reason that KVM is cool is that you can use some of your tools to manage your Unix users you can use to manage your virtual machines. And theoretically, it isn't as secure, but practically I don't have an example of why it wouldn't be any more secure. It's just different. And that's the big thing, is it's different, and I don't think one's better or worse. And the architectures came from different points of view.
Right.
And so KVM comes from a place where SE Linux is also highly developed, and those two things working together might have the same security things, but I don't know that there's a good way to debate that. And Mike might have some ideas too.
Yeah, sorry, I work with the Zen server. I'm a Zen server product manager, and I work with the Zen guys because we use Zen as part of our product as well. And yes, there are different ways of doing the security, and there are ways of doing similar to the SE Linux stuff in Zen as well. It's just at different levels, and I agree with Mark. I wouldn't be too worried about the Amazon thing, the fact that.
Yeah.
So I think that's an area where the Zen project, the thing that's been announced today, we've got some plans to really improve the tool stack on top of Zen, because Zen server has lots of stuff, obviously, but that doesn't map so easily. And the stuff that Mark's talking about, the XCP, that's kind of going away as a concept. We're just doing it better. Certain of the tools will be there in the same way, But there's just so much more we can do that we can put into the open source community, and that's exactly what we're going to be doing.
Yeah, I mean, everything wants it to succeed because we're really happy with it. So it's just a matter of it having the tools that we need, to, properly segment hosts and, multi-tenancy type issues that have been somewhat of a challenge with Zen, whereas, the other available solutions, open source and non, seem to kind of, that part doesn't seem to be lacking, but the usability, Zen is like top for sure.
Yeah.
Hopefully that's
So the idea of the Zen project, the Linux Foundation, is to get a lot of the smart people at Amazon and a lot of the smart people at Google that use it at scale to have there's always been a open source project, but just the idea that's under governance that's neutral is one of the things that help them participate, as many others.
To the best of my knowledge, Amazon, yes, used Zen because it was the first one. I work in big deployments of KVM, and the reason was at that time because Xen was still not part of the Linux kernel.
That's a good point.
That was why we went directly with KVM, because choosing KVM, Red Hat could provide support for the virtualization environment because it belonged and it was part of the kernel. Then later, Xen became part also of the kernel, so now the reality is what tools you like more. It becomes again the Emacs versus BI, MySQL versus Postgres kind of thing.
Yeah,
So.
and that's a good point, actually. That's a classic example of why you want to make sure that your patches are clean and good, because Linux will stop accepting your pull requests, and then you get out of the mainline kernel tree, and actually the Zen server team or the Zen project team has really done a good job of developing the PVOps project, which gives you the para-virtualization operations within the kernel so that you don't have the two-kernel problem, which is what you were talking about. It's a real pain in the butt. And actually, probably one of the reasons why people, for a while, were doubting Zen. Now I was just looking, Conrad Wilk is the Zen kernel maintainer, works for Oracle, and as early as 2 weeks ago, Linus was taking his patches, so it's healthy now. The rumors of its demise were greatly exaggerated, to quote Mark Twain. Yes.
Yes, you gave a list of different tools in terms of provision, configuration, automation.
Right.
I'm just assuming that we choose KVM hypervisor. Just wondering if somebody never started using any tools at all, and what would your top 3 recommendation in each of this area for somebody that's never used any tool before and start with KVM?
I don't have any recommendations just because I personally don't work with them. That's a good question. There's an ecosystem of like sort of ops center vendors for open source hypervisors. I know there's some for Zen, just because I work with those, that are just sort of virtualization orchestration. But on the KVM side, I don't personally know of any, but I would have to assume they exist. There's probably a Red Hat project. I don't know if like Overt, which is a project that keeps coming up, would be one that is a tool set for KVM. I think that's where I search for that and look through their archives. They'll probably have a lot of links. OVIRT. Yes?
To the last question, I'll be going into a little bit of that into my own presentation later on KVM and cloud computing in this afternoon. So, but I guess my question is, what I'm not very clear about is, yesterday the Zen project was announced as a part of the Linux Foundation. Today there are also, I believe, a lot of very rich management tools for Zen coming from the company Citrix. Are any plans to open source and contribute those management tools also to the Zen project community?
So I would say that in the last year, we have open sourced our cloud platform, which is a big management tool. We've participated in Project Daylight and Zen, the Zen project. So I would assume that that trend will continue, but I will not I can't make a promise here. But I would look at this summer and keep an eye on what Citrix does, because that is, our intention is to continue our open source stuff.
I can talk a little bit to that. It depends. There's so many tools at so many different layers of the stack, obviously. So in terms of the Zappy tools, the Zen API tools, which are part of Zen Server, those are actually already open source. They've been open source for quite a while. They are frankly impossible to build unless you're sitting in on the Citrix network with the 2 weeks of training you've had and all the dependencies, blah, blah, blah. We're going to fix that. So that, yes, they're planning to put those into the Zen project and to make them buildable and testable and all of that. So that's absolutely part of what we plan to do with it. That doesn't remove, the Zen project is about the Zen hypervisor, but allowing people to actually have the tools and use them is very much part of what we plan to do. Yes.
And actually,
feel free to talk to me later on.
Within the Zen project, I should note that the Zen Cloud Platform is sort of that attempt to have the tool set with the hypervisor, even though what Mike's talking about is even to agree. Yeah. So let's say our effort is there and our execution is getting better. And I think it also opens the door for other ones to do that.
So what about the HA functionality? That's actually not open source yet, is that right? Or does that, the live migration capabilities and all of that, I mean, is that?
Okay, so HA and live migration, kind of different things, really. HA, there are some bits there which are not open source, and we need to look into those. The live migration stuff is absolutely there and will continue to be there, including the live storage migration. There may be configurations which are a bit weird, and that's the sort of thing we need to well, we announced this on Monday, so yesterday, so we still got some ironing out to do, but we're working very hard on it.
You know, like what Amazon does as far as, various availability zones that are moving, VMs from one to...
No.
That's very...
Have they contributed upstream to the project?
They do contribute upstream. I think last year, roughly 5% of the new code that went into the Zen hypervisor came from Amazon. If they look at from the beginning of the year through November, so they do contribute. I think they'll do even more, but I think they're, as I said before, very secretive about their competitive edge is their service. So what they're willing to share, we're happy to hear, but I think that we want to make sure that's their prerogative to tell us what they want.
Well, that's their bread and butter.
Yeah, sure. Any other questions?
Doing with,
What's that?
What's Google doing with Zen, and what have they contributed?
So Google's pretty new to the project. Well, I shouldn't say that. So they have the Genneti project, which I didn't put that on the IaaS thing, IaaS slide, because it's more virtualization orchestration. So pretty interesting. That is what they use to run their engineering clouds. It's all very customized, but they use Genneti. They are hosting a hackathon on May 15th and 16th in Ireland at the Google campus. So they are contributors to the project through their various huge engineering core. But they run internal clouds on it. They probably run a lot of stuff. I just know that the Genneti guys have, like, their engineers work on Genneti clouds and things like that. Yeah.
Thank you. For Google now, sometime back, I think there was some announcement that the Google Compute Engine is based on the KVM hypervisor, and so therefore I'm a little bit of confused now.
Yeah. So I would expect, if I am a big company, I'm going to hedge against multiple technologies. I would guess that Google does not have a big vCloud VMware installation, but if I were Google, I would be investing in KVM and then just to make sure I had, had multiple hypervisors. IDC, the analyst firm, this year said that 60% of organizations using virtualization this year will add an additional hypervisor, which I find to be fascinating, that they will have multiple hypervisor strategies. You know, I would like everyone to use Zen, but I would think that you'd be remiss not to be looking at everybody else's solution. And Google has so much IT. They're the world's biggest IT company. I mean, I would assume that I'm sure they have VMware somewhere too, but I would say at scale they probably want to check out KVM and Zen at the same time. And there's, as I said earlier, they're big enough to have multiple use cases, as do most of you have multiple use cases. Any other questions? Does that make sense? It's a lot of stuff to cover in like an hour, a lot of stuff. But I was hoping that if you get the slides, it has all the links there. And those slides are, the links are what I think are useful so that you sort of have a place to look at. Because I'm not really recommending one over the other, except for Zen and CloudStack. As I said before, I'm prejudiced that way. But I think that we want to give you guys the choice to build your cloud and know what those components out there are. So thanks for everything, and have a good conference.